Hi, good afternoon, everybody. My name is Julius Emig. I'm a research associate and team leader at Fraunhofer, Italia. We are a small research center, mainly for applied research in northern Italy in South Tyrol. And we work also on topics like digitalization and automation in construction. And today I brought to you this topic that I worked on with my colleagues from the Institute. It's about automized planning and data exchange for prefabricated facade renovation processes. What motivated us to work on this topic was basically the slow renovation rates across Europe, and on the other side the ambitious European climate targets, let's say, that require for lower energy demands of the existing building stock, and thus a renovation of the existing building stock that advances a little bit faster than it's currently happening. One thing that, or one approach that is often mentioned are the usage or the rely stronger on prefabricated facade systems because they allow for higher degrees of automation due to the prefabrication fact, and reduce also the on-site time for installing and constructing. On the other hand, they require a higher planning effort, and the whole tool chain, let's say, is a little bit more fragmented compared to ethics or conventional ethics facade insulation. So we have to consider survey, planning, production, and logistics workflow somehow. To reduce the planning effort, we have to streamline some digital and data continuity, let's say. And that's what we worked on in this paper, on the digital workflow, let's say. Before I come to the proposed workflow, I just quickly want to bring everyone on the same page related to the process itself about facade renovation. So here is like a, let's say, ideal workflow that we want to capture with in terms of data and digitally, to have a complete data continuity along this line that you see here. It starts from the survey, which can be any kind of 3D laser scan, for example. There are also other methods, but currently a lot is done in 3D laser scanning, outputting some sort of point cloud. Then we have the planning aspect, which should require as less manual input from some planner, architect, or engineer as possible. Then we have the prefabrication, so production in the factory, and then the logistics, assembly, and disassembly. That are steps that in this work we didn't focus that much on, but to complete the process they're also mentioned here. Related, or to introduce quickly our proposal, let's say our proposed architecture. You see it here. It starts exactly with that site survey. We decided for 3D laser scans as input, mainly point cloud files that are then can be or there's a second block then which are web interfaces, or let's say something the user would interact with. So there we rely on open source technologies like 3JS and that open company. We provided some tools for automatic panel generation or panel layouts, let's say, generation, some packaging tools. So this is just, let's say, a container for all sorts of tools that you might need to streamline this data flow. And then there's the backend where some processing of the point cloud happens, like some facade detection or plane detection algorithms are running. And as let's say, as a central data layer, we decided to use a self-hosted Speckle server because it already offers quite some nice or clean versioning, and handles all the project and user management, let's say. To make this a little bit more tangible, let's say, there's a case study that we looked at, and where we, after implementation, applied this this workflow too. On the left side, you see here a point cloud of a facade from Bolzano, captured by a Faro 3D laser scanner. And on the right side, you see just two examples for, on the left side, some in-house developed small size wood fiber prototype that can be prefabricated, that is closer to classical attics solutions, and on the right side, typical full story height timber module, and we try to capture both of those solutions to give the full range, or at least to test if this is feasible. Then let me speak quickly about the automized planning part of this work. So here you see on the left side the generated facade plane in 2D from this point cloud, and then on the right side you see the generated panel layout, in this case for the small size panels. And for the panelisation, or let's say layout generation, we just implemented some simple rule-based algorithm. It works based on these grid lines that you see in red, that can be automatically retrieved from the outlines and the window openings, but also manually modified, let's say, in the web interface. And from there we have several outputs, of course, the individual panel geometries and material quantities, mounting positions, and we store them, or let's say we wrote a small IFC exporter for this that brings them in IFC-compliant format, and then sends them to the backend and stores them in our Speckle data layer also. But yeah, both ways are possible. Let's say the IFC downloadable directly via an IFC file, or retrieve them later on. You will see it also in a small demo that I show you afterwards, directly retrieved from the backend. And those can be used then, of course, later for downstream processes like logistic installations, LCA, LCC, and production processes. Then for the finish, I just have some small demo video. I'm sorry, it's quite fast due to the time, but you will see in the main steps. This time based on the example of a full story height module that we saw also, or a similar one that we saw in the picture. I just start the video. This is it started. This is some basic authentication, and the main dashboard with the different tools. Let's say we will enter in the 3D planning, and you will see how a user could interact with this detected facade planes and create this panelisation layout. Let's say here we also have some indoor data, so we can retrieve the mounting points for the story height panels already based on the slabs, or based on the concrete slabs of the building that are scanned. And the panelisation is like, or it requires not so much user interaction, but of course we gave the possibility to have some modification also in terms of planes. Of course, this automation of the planes does not work perfectly. There are some manual adaptations required. And here, this is just the logistics part, which works then on the same data now, and just a simple bin picking algorithm implemented, to calculate the amount of containers, and to give a little bit of the logistics part on. Okay. As outlook, I mean, we will further work on more complex geometries, also the facades that you saw in the demo and in the test case. They were quite simplified. Also things like balconies and just things we didn't, or complex geometries that stick out of the facade, we didn't tackle so far. Then within this overall project, also other partners work on the LCA, LCC integration and the production link. This is also forthcoming, and in the end also the installation sequence and site logistics. We will look into this more in detail. And then I'd like to thank you for your attention, and happy to discuss any questions or comments there are my contact data, and yeah.
Thank you. Thank you, Julius, for your presentation.